Dear students, in this lecture, we are going to learn about the evolution of operating system. So as we have learned that the operating system has been evolved over the time. The reasons were the hardware technology upgrade, the need of more functionalities, also the security and the loophole fixes, the bug fixes are the reasons for the operating system evolution. So initially it was a very simple system. So as we know that the first computer that was made, it is a purely hardware. So there was a very little part of software existed that time. So the simple batch processor system came very later after that. So what is exactly simple batch system? The processor in the simple batch system, they used to batch together the similar tasks and they used to give that task to the machine and the machine used to perform the similar task in the particular period of time. And when the task will be completed, the output will be given to uh, the people who are requested a task. So it there was a some manual effort also there because you have to batch together tasks and you also make sure that the output will be there. So here is the concept of uniprogramming comes. Uniprogramming means what? So at a one point of time, you are only performing in the one task and your whole system is dedicated to perform only one task. So in this time, in the simple batch system, processor time alternates between execution of user program and execution of monitor. So when what is the monitor? The monitor in simple batch operating system is just like a OS that is working right now. So this monitor used to make sure that all the similar tasks are being batched together and that being performed. So this monitor will monitor the whatever processor will perform. So processor is a hardware device. So processor doesn't have its own intelligence. So what to perform, what not to perform, and how much to perform. So only there has to be some extra mechanism. Whether initially it was a human used to tell the machine that what is the task that has to be performed, and the machine used to perform that calculation of the task. In case of simple batch operating system, you got a concept of monitors. So monitors were like just a scratch of program that were be that was actually the logic that will tell the processor of which program has to be executed, which task has to be executed. So in this case, the what is the overhead is happening. Some main memory has to be dedicated for the monitor because monitor has to be existed in the system itself. So monitor was a part of all the system executions. So mostly the main memory is being used by the monitor only. Some processor time is consumed by the monitor also because the monitor will be telling the processor which supposed to be the next instruction to be executed. Okay, so as we know that what is the main memory? There are two types of memory. That is a secondary memory and there is a one main memory. So what is the main memory? Even though we have a secondary memory, why do we need a main memory? Because the secondary memory is a permanent memory. And the secondary memory do not directly deals with the processor. The processor only deals with the main memory. So whatever you want to run on the processor has to be brought into the main memory. So whatever you are using on your laptop, your mobile, that is in the main memory. So you are running a program, you are playing a game, you are playing something, you are editing some document, that is in a main memory. Even though you have a document saved in some file, that is in a secondary memory. When you open that file, the copy is being created in the main memory. That file is being brought into the main memory and that the task is being executed. So this is the what all about the main memory is. So when you know that the main memory is very crucial, so when you need to have some space in the main memory to execute the programs. So in this case, the monitor is using the somehow the space and monitor also taking some time of processor. So this is a simple batch system overhead. Even though the overhead was there, it is much better than the initial computer. That was hardwired computers and the human intervention was needed. Next, the multi-program batch system. So whatever the simple batch system was doing, that was the uniprogramming. So what it was doing, it is doing the only one task at a time, and the whole system was dedicated for the one task. So what is a multi-programming concept then? So for example, if there is a task are like reading from a file, executing those instructions, writing those instruction. So there is a total three tasks that has to perform by system. So they have given that some microsecond time that each activity will take. So that is a total 31 microsecond. So out of all these activities, if you see that the execution of instruction is only for 1 microsecond. So out of all this, 31 microsecond because reading a record, writing a record is not a processor task. Okay, that is not CPU task. Processor CPU is the same thing. Okay, so that is the processor task. So what will happen at that time? The CPU utilization will be very minimum. That is just a 1 by 31. That is a 0.032. That is a exactly 3.2%. So for this 31 microsecond, only for 3% of time CPU is being utilized. And what is the motto of processor? What is the multi-programming concept is all about? To utilize the CPU efficiently. So in simple batch system, we are not using the CPU efficiently because whenever the CPU is working, it is utilizing, and if whenever CPU is not working, so some other task is happening, CPU is idle because CPU only performing the task whenever there is a task to perform. So otherwise it is idle in simple batch system. So in multi-programming, why we need a multi-programming? Processor is often idle. Why? Because even with automatic job sequences, for example, there is some IO task is happening, so processor doesn't have anything to do. So it will sit idle. So in multi-programming batch system, we came up with the idea that we will perform more number of programs at the same time. How? See, they look at the uniprogramming concept. In the uniprogramming concept, there is a program is running. Okay, so there is say some IO device task is happening. So you will be in a waiting mode. So you means I'm talking about the processor, and then you are again running. Then again you are in a waiting mode. So uniprogramming means what? You have a single task. You have a single task you are performing. So whatever happening in that particular set of program, set of instruction, the processor work accordingly. So processor spend some amount in execution, sit idle for a time until it do its other work, other stuff, that is IO instruction, and it will again execute, again will sit idle. That is what we call uniprogramming. Then what is multiprogramming? In multiprogramming, we are thinking about the utilization of processor. So multiprogramming means what? You're having a say program A and program B that has to be executed. So whenever program A is running on the CPU, it's very obvious that no other process will be executed because CPU can perform only one program, one task at the same time. So multiprogramming is not what you think. Multiprogramming doesn't mean CPU perform four tasks at the same time. No, CPU only perform one task in the one time only. If it is a unicore processor, single core processor, it will perform only one task. So whenever that program A will be running, other processes, other program will be waiting. When that program A will go for some IO device task, CPU will be idle. So we should not keep the CPU idle. What we will do, we will keep it engaged on the program B. Okay, so there is a program B that it will have say some 100 instruction, it will be performed. Again, that program B also waiting for some IO devices. Meanwhile, the program A has completed that IO device task. It will again run on the CPU. So see, there is, if you combine this, there is some amount of time is being merged. So the CPU utilization, if it would have been a single processing system, single programming system, uniprogramming system, we would have performed program A and they program B. But in case of multi-program, we will be combining this execution. So program A and program A will be executed simultaneously, but not overlapping with each other. That is what we call multi-programming. Here we are giving only two program examples. So you can just imagine there are lots of programs, lots of instruction happening in the operating system. So we can simultaneously execute them. So there must be enough memory space to hold this amount of program. Okay. If one job needs to wait for IO device, processor can switch to the next program or the next task to be executed. So multi-programming is also multitasking, and memory is expanded to hold 3, 4 more further depend on what is the size of your main memory you are having. So just see the example of task 1, task 2 and task 3. So this the task 1 is a very heavy computation, task 2 is a heavy IO device based task, and the third one is a heavy IO device based task. So these are the some requirements they have been given. So how much time the task 1 will need, how much time the task 2 will need, how much time the task 3 will need. So this is the duration, 5 minutes, 15 minutes, 10 minutes. The memory required they have given. whether they are needing these terminal printers. So see, whatever we are talking about, the memory, duration, and all, these are the resources of the system. So operating system will have main memory, operating system will use the processor. So how, not necessarily all the tasks will need a processor. Some tasks will need only IO devices, some tasks will need only terminals, some tasks will don't need terminals, some tasks will don't need printer. So the requirement will vary. So considering this three example, if you see that if you would have the uniprogramming, the first task one will be executed. So task one says that I'll be executing for 5 minutes with the 50 MB memory. Okay, so the if you see that the graph one, the A graph, there is a CPU utilization, then memory, then disk utilization, and then terminal utilization and printer. So this whole 30 minutes will be executed for only one task. Okay, so here the 1 minute of the task one is only happening in the 30 minutes. Okay, the overall task of three combinedly happening for the 30 minutes. So what is happening? The task one will take a 5 minutes, the task two will take a 15 minutes, and the task three will take a 15 minutes, 10 minutes, sorry. So total is 30 minutes. So what is the happening here? The tasks are happening, but in a sequence. So somehow, even the task 2 doesn't need IO devices. It will still wait for a CPU because it's uniprogramming. That is the drawback of uniprogramming. In case of multiprogramming, if I see that there is a task 2, this does not needing the heavy computational processor, can I engage the task 2 in IO devices and having my task 1 to be executed on a processor? That is what we call overlapping. This is overlapping is happening in a multiprogramming but without interfering with each other. So if task 1 is using CPU, no other tasks are using that CPU. So here you can see that the CPU is being used by all the three tasks but not at the same time. Here the printer is used by only task 3. So if you just combine all these three, you will just see that in 15 minutes is done. So in the 50 is just a half of the uniprogramming time, your task is being done. Because what? Because until when the task 1 was executing on the processor, you did your heavy computational, heavy IO device task. Same goes for a job 3. Considering that they both require two different IO devices. So this is how the multiprogramming works. So if you see that use utilization, it is much more in a multiprogramming than the uniprogramming. The percentage is almost double. So uniprogramming, one program at a one time, multiprogramming in a memory concurrently. So they are multiprogramming doesn't means processor will execute all the programs simultaneously. That is the wrong definition. Multiprogramming means in a main memory you can execute your program simultaneously but without interfering with each other. So in uniprogramming, obviously low CPU utilization. In multiprogramming, you will have a more complexity will be lesser because you don't have to deal with the overlapping parts. So you don't have to worry about which task is using what. In case of multiprogramming, you have to take care about scheduling because no two processes will execute on this processor at the same time. The performance will be lower at this side and higher on that side. Lower memory usage, higher memory usage. Okay, so MS-DOS, which was a very early computer system that used to use uniprogramming and the multiprogramming, that is right now we are using with Unix, Linux, and Windows. So what is the time sharing system? The time sharing system, why they came? So if you see that what is the drawback of multiprogramming, if we can imagine what would be the drawback of multiprogramming. So the recent example we have taken, there was a task 1 who needs CPU. But there are task 2 tasks it doesn't need CPU. So that was fine. But in considering the overall instruction that is being executed in CPU, how many processes will want the CPU to be executed? Say from 1000, there will be 500 processes that will need CPU, and they might be needing the CPU at the same time. So what CPU will do? So you don't have a choice. You will have to wait all those processes in the queue. That will be first come first. So whoever will coming first, that will be getting the CPU. But whatever the other processes will do, they have to wait. That is that is a drawback of multi-programming because you have the limited resources in the operating system. For example, the main memory is limited. You have the limited IO devices. You have a one processor if you are considering a single core uniprocessor system. So you having these devices, you having this memory, but they are limited. So if some two programs wanted to access the same memory location, they should not be allowed. So that they have to wait for that particular chance. So that is why the queuing concept is there. That is, you have to wait in a queue to get a chance to be executed. So that was somehow unfair for the processes or the tasks that are waiting. So there has to be some fairness. So that's where the time sharing system comes. What happens in the time sharing? The processor time is being shared in the multiple users. So each user will get say 2 microseconds for CPU. So they will be waiting in a queue, but in a round robin, they will be getting a chance to be executed on CPU and unless waiting for the 100 process to be executed and then the 101 process will get its time. No, what will happen? Each process, each user simultaneously access the system. Okay. So multi-programming is still there. Multi-programming will be still there, but what you are doing, you are utilizing those resources in a round robin fashion. That is what we call time sharing system. So what is the difference? The principal objective of batch programming is the maximizing the processor usage. So you are more focusing on the processor utilization. In time sharing, you are focusing on the minimizing the response time because if you are multi-programming, you need a processor and there are 100 processes that are waiting. So the 100 process will have the maximum delay, the response time. So we don't want that response time has to be minimized because the process cannot be wait for a longer period of time. So in that case, the time sharing in a round robin fashion, that processor will get its access immediately rather than in a uniprogramming or you can say multi-programming. So it will minimize the response time. In the batch programming, job control language commands are used. In these commands entered at the terminal in the time sharing system.